Hi everyone, today we will learn TCP/IP protocol suite. So let us start. Suppose two persons are to communicate with one another. To communicate successfully, they should be sharing a common language. Therefore, both ends should be able to understand what the other person is saying. Similarly, in computer networks, the computers should be sharing a common message format. They should know how long the message is, which part of the message is the actual data, which part of the message is the sender's and receiver's address. Such information will result in successful communication between computers. If one computer speaks ASCII and the other one speaks Unicode, successful communication will not occur unless they are prepared to perform translations back and forth. So, some ground rules are required to communicate successfully. In computer networks, the agreed upon set of ground rules that make communication possible are called protocols. TCP/IP is a set of protocols that support network communication. But what is network and what is communication? In the most basic form, two computers connected via LAN cable sharing data with the help of network interface cards forms a network. And the process of sending messages from one place to another through a wired or wireless medium is called communication. The message can be a file, a voice conversation, a streaming video, or anything which can be communicated in digital form. These messages are not sent as a single unit. Instead, they are broken into small data units. These data units are transmitted through the network and restored at the receiver into the original message. In TCP/IP protocol suite, TCP breaks messages into smaller data units called segments and hands them off to IP, which deals with routing segments through the networks to their final destination. TCP module in the receiver combines the segments to form the original message. Note that TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. An alternative to TCP is UDP. It stands for User Datagram Protocol. The main difference is that TCP is highly reliable but it is slow, whereas UDP is less reliable but generally faster. Both TCP and UDP are a part of the protocol suite. However, due to heavy dependence on TCP and for historical reasons, the entire set of protocols is referred to as TCP/IP. TCP/IP is a network model designed to support network communication, even if the computers are from different manufacturers. There is one more network model called OSI model or Open System Interconnection Reference Model. It is primarily used for research purpose. On the other hand, TCP/IP is a practical model and developed to meet the needs of original internet design. As per the name, TCP/IP seems to be a set of two protocols only, TCP and IP. However, it consists of numerous protocols bundled at different layers. The topmost layer is the application layer, which generates a message. The message is passed to the lower layers at the sending node, where each layer encapsulates the message from the above layer. So the message sent becomes larger and larger as it passes down the chain. The data unit in the data link layer is called an Ethernet frame. In the network layer, it is called an IP packet. If it is in the transport layer, it is called a TCP segment in case of TCP protocol and UDP datagram in case of UDP protocol. In the application layer, it is called an application message. The peer layer removes the header at the receiving node and passes the remainder upwards layer by layer till the message finally reaches the application layer. Let us discuss each layer one by one in more detail. We are starting with the bottommost layer, the physical layer. The physical layer is the place where actual communication takes place. We know that a sequence of zeros and ones digitally represents the messages. The physical layer converts this binary sequence into signals and transmits them over the local media. The signal can be electrical if the local media is copper cable or LAN cable, the light signal in case of optical fiber, and a radio signal in case of air or vacuum. So, the signal generated by the physical layer depends on the type of media used to connect the two devices. The most common protocol used at the physical layer is Ethernet. The protocol also specifies the type of cables that can be used for data transmission. For example, if the protocol used is Ethernet, then twisted pair cable, coaxial cable, and fiber optic cable can be used for data transmission. If the protocol used is fast Ethernet or gigabit Ethernet, then twisted pair cable or fiber optic cable can be used as local media. Next is the data link layer. The data unit in the data link layer is called an Ethernet frame. The data link layer is divided into two sublayers, medium access control or MAC sublayer and logical link control or LLC sublayer. The MAC sublayer is responsible for data encapsulation and accessing the media. In data encapsulation, the MAC sublayer adds a header and a trailer to the IP packet received from the network layer. The header contains the MAC addresses of the sender and receiver. The trailer contains 4 bytes of error checking data used to detect errors in the received Ethernet frame. What is MAC address? It is a unique 6-byte address embedded in the network interface card of a device by its manufacturer. For accessing the media, the access method Ethernet uses is called Carrier Sense Multiple Access with Collision Detection or CSMA-CD. In this method, each computer listens to the cable before sending data through the network. If the network is clear, the computer will transmit. If the first computer is already transmitting on the cable, the second computer will wait and try again when the line is clear. Sometimes two computers attempt to transmit at the same instant. When this happens, a collision occurs. Each computer then stops transmission and waits a random amount of time before attempting to retransmit. Please note, with this access method, it is normally to have collisions. However, the delay caused by collisions and retransmitting is very small and does not normally affect the speed of the transmission on the network. The next is the LLC sublayer. It offers flow control and error control. Flow control is a technique that restricts the amount of data that a sender can send without overwhelming the receiver. The receiving devices have a limited processing speed and a limited memory to store the incoming data. If these limits are exceeded, then the incoming data will be lost. To avoid this, the receiver should inform the sender to slow down the transmission rate before these limits are met. In the data link layer, flow control restricts the number of frames the sender can send without overwhelming the receiver. Error control in the data link layer refers to error detection and retransmission. Error detection is done by using the error checking bytes added in the trailer of the frame. The frame retransmission is done using automatic repeat request or ARQ. The receiver sends an acknowledgement to the sender when a frame is received. When the acknowledgement is not received, the sender sends the frame again. So if a frame gets lost or damaged, then the acknowledgement is not sent. As a result, the sender sends the frame again. This process is called automatic repeat request or ARQ. LLC sublayer can also resize the IP packets received from the network layer to fit them in the data link layer frames. The transport layer provides most of the services of the LLC sublayer, including flow control, error control, and sizing of packets. Therefore, the services of the LLC sublayer are usually bypassed. The remaining 3 layers of the TCP IP protocol stack, including network, transport, and application layers, are implemented as software programs within the computer's operating system. Starting with the network layer. The transport layer passes TCP segments or UDP datagrams to the network layer. The network layer adds logical addresses or IP addresses to the TCP segments or UDP datagrams to form an IP packet, and then uses routers to send the IP packets to other networks. The network layer also determines the best path for data delivery. So the functions of network layer are logical addressing, routing, and path determination. IP is the single standard protocol for this layer. Every computer in a network has a unique IP address. The network layer assigns senders and receivers IP addresses to each segment or datagram to form an IP packet. IP addresses are assigned to ensure that each IP packet can reach the correct destination present in different networks. Routing is a method of moving an IP packet from source to destination present in different networks. Routing is not needed if the source and destination computers are present in the same network. For communication within a network, the task is usually simple. The ARC module takes the destination IP address from the IP packet and returns the MAC address of the destination computer. It is then used to create an Ethernet frame which is delivered directly to the destination as it is present in the same network. That is, no routing is needed. However, when the message is being sent to a node outside a network, for example to the internet, the network layer moves the message from the sender to receiver through routers. Consider two networks connected with a router. Computer A needs to send data to computer B. Please note that both computers are present in different networks. Hence, in this case, routing is needed. To create an Ethernet frame, we need the MAC address of the destination computer. However, in this case, the destination is present in different network. So, the ARP module cannot provide us with the destination's MAC address because it can provide the MAC address only if the computers are present in the same network. So, the ARP module in network 1 cannot provide the MAC address of the computers present in network 2 and vice versa. Since the intermediate to the networks is the router R, the destination MAC address is kept as the router's MAC address, and the frame is forwarded to the router. Router finds that the MAC address in the frame matches its address, so it extracts the IP packet from the frame and forwards it to the network layer. The network layer finds a mismatch for the destination IP address, so it sends the IP packet down to the data link layer and updates the destination MAC address with the MAC address of computer B. But how router knows the MAC address of computer B? Simply by using the ARP module. It is one network, so the ARP module works here. Finally, the Ethernet frame is delivered to the computer B. Please note that the destination IP address never changes for inter-network communication, but the physical address or the MAC address changes with every hop. So, IP addresses are a must to transfer data among multiple networks. Now, path determination. A computer can be connected to an internet server or a computer in several ways. Choosing the best possible path for data delivery from source to destination is called path determination. Layer 3 devices use protocols such as Open Shortest Path First, Border Gateway Protocol, Intermediate System to Intermediate System to determine the best possible path for data delivery. Because routing takes place at the network layer or layer 3, routers and gateways are sometimes called layer 3 switches. IP is unreliable. It does not guarantee delivery nor check for errors. These tasks are the responsibility of the transport layer. Let us start discussing the transport layer. At the sending node, the transport layer receives messages from the application layer. When the message reaches the transport layer, one of the transport layer protocols, that is TCP or UDP, is selected. TCP supports segmentation, so if the message is large, TCP divides it into smaller pieces and adds a header to form a TCP segment. On the other hand, UDP does not support segmentation, so the applications using UDP should send messages short enough to fit into one UDP datagram. Note that the data unit in TCP is called TCP segment and the data unit in UDP is called UDP datagram. UDP datagrams are considered unreliable because there is no guarantee that all datagrams sent will be received in the destination and in the correct order. So if reliability is needed, UDP should not be used. UDP lacks error checking and correction. It makes UDP fast and efficient for DNS, DHCP, SNMP, and RIP protocols. UDP is also suited for streaming videos. TCP, on the other hand, is reliable and guarantees in-order delivery of data from the sender to the receiver. The data transmission via TCP has three phases: connection establishment, data transfer, and connection termination. In the connection establishment phase, the sender TCP or client sends a packet to the receiver TCP or server requesting a connection. The server then sends an acknowledgement to the client. The client further acknowledges the server. It completes the process of connection establishment. Since a connection is set up before data transmission, TCP is a connection-oriented protocol, and the connection establishment process is called three-way TCP connection handshake. Once the connection is established, the next phase is the data transfer. During data transfer, TCP offers some key features which UDP does not provide, and it includes error-free data transfer, ordered data transfer, retransmission of lost data, discarding duplicate packets, and congestion throttling. Let us discuss each feature one by one. Error-free data transfer is provided by using the field checksum. The sender calculates and enters a value in this field. At the receiving end, the receiver performs the same process and calculates the checksum value. If it does not match the value present in the checksum field, the TCP segment is discarded and no acknowledgement is sent to the sender. Because the sending side does not receive an acknowledgement of the discarded packet, it is retransmitted. This time, the checksum value calculated at the receiver matches the one present in the TCP segment. It means the TCP segment is correct and it is accepted. In this way, TCP helps with error-free data transfer. Ordered data transfer. TCP adds a sequence number in the TCP segments. At the receiving end, TCP module uses the sequence numbers to construct the application message in the correct order. Retransmission of lost segments. For reliable data transfer, the receiver TCP sends an acknowledgement to the sender TCP for each TCP segment it receives. If acknowledgement is not received, TCP segment is retransmitted. Therefore, if a TCP segment is lost, the receiver will not send an acknowledgement message to the sender. As a result, the sender TCP sends the lost segment again. Discarding duplicate segments. The TCP client retransmits segments that it determines to be lost. However, the receiver TCP may receive segments that were considered to be lost. As a result, the receiving end will have two or more copies of the same segment. In such cases, the unique sequence number in the TCP header of every segment helps to determine the duplicate segments, which are then discarded. Congestion throttling or flow control. The goal for TCP is to send segments to the receiving end as fast as possible without losing them. When TCP first sends the segment, it sets a timer. If the segments are acknowledged before the timer expires, the TCP increases the transmission speed until the segments begin to become unacknowledged. Since the acknowledgement for some segments is not received within the time, the sending TCP module retransmits the segments. When a significant number of packets have to be retransmitted, TCP slows down the data transfer rate. In this way, TCP handles congestion throttling or flow control. The last phase in the data transmission is connection termination. When an endpoint wishes to stop its connection, it sends a finished message to the other endpoint. The other endpoint acknowledges the message. Both ends do this two-phase handshake process. Therefore, the connection termination follows a four-way handshake process. So this is the way how TCP handles data transfer. Now, the topmost layer in the TCP IP protocol suite is the application layer. The application layer is used by user applications that pass messages from one computer to another in a network. For example, Google Chrome, Firefox, Microsoft Outlook, and so on. They use application layer protocols to perform their activities. For example, web browsers use HTTP or HTTPS to do web surfing. Email programs such as Microsoft Outlook use Post Office Protocol or Simple Mail Transfer Protocol for transferring emails. So, the application layer provides means to access information on the internet. This is the list of protocols provided by the application layer. Domain name system translates IP addresses to domain names and vice versa. Dynamic host configuration protocol automatically assigns IP addresses to computers present in a network. File transfer protocol is used to transfer files on the internet. Hypertext transfer protocol is used for sending and receiving web pages. Internet message access protocol is used for email messages on the internet. Internet relay chat protocol is used for internet chat. Post Office Protocol version 3 is used by email clients to retrieve the messages from remote servers. Simple Mail Transfer Protocol is used for email messages on the internet. So these are the 5 layers in TCP IP protocol suite. If you have learned something from this video, then please like this video. Share this video so that more people can learn. Subscribe to Tech Terms if you want to learn more and turn the notification icon on. Thanks for watching.